I'm back, round two. All right, so data analysis. So we examined the research question with a one-tailed z-test, and the z-test was a proper measure to use because when using a z-test, the sample size has to be greater than 30, which it was 40. All observations are independent of each other. That's another requirement. And the first means we compared were between uniforms and academic success. And the second means that we compared were between uniforms and behaviors in high school females. So those were the two things that we were really curious to find out if there was any sort of significant results from that. And so from the final sample, the data we collected were once again 40 respondents. We used 4 of our content questions to answer one of our hypotheses and the other 4 content questions to answer the other hypothesis. We added up the 4 scores off of the Likert scales and then calculated the descriptive statistics to find out the mean, which is M, as you can see up on the screen, standard deviation, and the standard error mean, which is SEM, and standard deviation is SD. Based off of that information, we were able to find out the z-test for a single mean. So yeah, as you can see up on the screen, there was the descriptive data table. There were a couple things that I personally kind of wanted to point out to you about this. Although both of our hypotheses were correct, we wanted to point something out to you. The majority of our means, medians, and standard deviations were relatively close to one another, except for the last content item. The majority of our respondents were split evenly on whether they thought that uniforms should be worn or shouldn't be worn. And so that is why the standard deviation is higher, because there were more discrepancy in the respondents. And as you can see, like I said in the last one, which is students should wear uniforms, the standard deviation is at a 0.81, where all the other ones kind of range between the 0.6 to 0.7-ish range. So when you have a higher standard deviation, the more discrepancy there is. A lot of the medians, as you can see, the responses were like an average of like 2 to 3, so that's kind of why they're right there in the middle. And so on our Likert scale, like Alyssa had already said, 1 was strongly disagree, 2 was disagree, 3 was agree, 4 was strongly agree. So that's kind of how we added up our results to find out the mean, median, and standard deviation. And then as you can see with the mean, they're kind of averaged between 2 and 3. So yeah. The test of the hypotheses. For the first hypothesis, people see uniforms as beneficial to academic success. We were able to reject the null hypothesis because the z-test that we had for the single mean was outside of the boundary of 2 standard deviations. So the z was 27.36. We need to be above 1.64, which we were way above. So we were able to reject that, which means that we were correct with our hypothesis, which, yes, good job, yay, us, yay. For the second hypothesis, people see uniforms as managing behaviors in female high school students. We also were able to reject that null hypothesis because the z-test for the single mean was outside the boundary once again of the 2 standard deviations with a z-score of 28.12. So once again, way out of the ballpark with that z-score. Going back again with testing both of our hypotheses, the first one, the mean was 9.85. The standard deviation was 2.28. The standard error mean was 0.36. And then on the second one, the mean was 9.28. The standard deviation was 2.10, and the standard error mean was 0.33. So yeah, that's it kind of for our results section. If you would like to go back and like look at our table or anything again, just ask Patty or Alyssa, and they will gladly kind of go back to our table later on in the presentation. I hope that the rest of you guys do an awesome job, or if you already went, I'm sure you did great. Have a great rest of your summer, and hopefully I'll see some of you guys back in the fall. Bye.